Our second video on vector calculus, we're looking at interesting context here, collisions. So when things hit each other, and that's always interesting. This one's essentially a worked example which uses a lot of the stuff we've recently learned. A particle P begins from a point 10j meters and continues with constant velocity 2I minus j meters per second. 1 second later, a second particle Q starts at a different point 2I plus 15j meters. And it moves with a constant velocity as well of 2I minus 5j meters per second. We've got to do three things with that. We've got to show that the particles do actually collide, and that means they're in the same place at the same time. Okay? It's got to be the same place at the same time, and the same place is not sufficient because that just means they cross paths, but they actually collide if they're in the same place at the same time. Secondly, we've got to find the Cartesian equations of their paths. And lastly, find the Cartesian coordinates of the point of collision. Okay, and we're going to use a bit of graphing as well as a bit of algebra and calculus. So for each of these, we've got a velocity vector given, and we've got vector valued functions. So just be aware that when we write v of p, that's the velocity or the r dot for particle P, and it's a vector valued function, so it's in regards to t. So sometimes the notation includes the t and sometimes it doesn't. Okay, so from our previous video we know for particle P, to find the position vector we have to integrate, and you can see the results there. Now we get a constant vector. From the last video you would have seen this. We're given that its initial position for P is 10j, and if we subbed in, like in the previous video, t equals 0 for the expression above, we would find that C1 is actually 10j itself. See the previous video. So we've got an expression there for the position vector of P with regards to t, and we can just group the I and the j components just like we did in the previous video. So we would have plus 10 minus t group of j. So in the same way with particle Q, we have to find the integral of velocity vector given, or the integral of r dot for Q, and we've got the velocity Q is 2I minus 5j, and we integrate and we get 2ti minus 5tj plus a different constant vector which we'll call C2. And since we've been given above for t equals 0, we know that C2 equals 20 in the same way as we've been doing in previous questions. And that's based on the given information above there. Okay, but the only difference is that this one here says 1 second later. Alright, now some questions will be sequentially or simultaneously. Simultaneously, in fact. That means at the same time. This one is not simultaneously, this is 1 second later. So we've got to do something here. The thing to remember here is that we are substituting in, with 1 second later, we're substituting in t equals 1. They have to both be on the same clock, quote unquote. They have to be on the same timelines. So this will, its initial will be overall, for the, in the big picture of things, it'll be t equals 1. So we're going to substitute in t equals 1. So that will provide 2i plus 15j equals 2i minus 5j plus that C2. Now again, that's because it starts, Q starts at 2i plus 15j meters, its position, and that's got to match when we've got the position vector equation with t equals 1 subbed into it. And that's how we can find that C2 equals 20j. So we sub that in and we collect things in terms of vectors I and j, directions, and 20 minus 5t, and we've got the j directions sorted out there. Got to make sure I put my tildes in there. Alright, so collide means same place at same time. Okay, so that means the position vectors will be equal for some value of t. And that's the great thing about our vector valued functions with time as a parameter. This will allow us to find it. So now that we know the components must be equal, we equate the components because the components must be equal. For the I components, it's fairly trivial, as you can see. Now for the j components, we've got 10 minus t j equated to 20 minus 5t j. So 10 minus t must equal 20 minus 5t, so t must equal 2.5 for that to occur. So they collide, the collision happens 2.5 seconds after p starts moving. Because the clock t equals 0 is based on p. It was the first particle to be fired off. So that's when. So what we've shown is that they do collide, and we've shown when it happens. Now for the next part, part B, the Cartesian story. Remember, Cartesian is x versus y, so it's direction versus direction, or a length versus a length. And so if we get r of p from before, we've got 2ti, Mr. Herbert, 2ti plus 10 minus tj, and remember that's equivalent to xi plus yj. It's equivalent to that. So parametric equations, x equals 2t and y equals 10 minus t. So we've got y versus x, we can do a substitution there, and we can get, rearrange it first actually. We can replace t by x over 2. If we want the Cartesian, we've got y versus x, so we can go y equals 10 minus x on 2. Okay, or negative x on 2 plus 10 if you prefer. So that's the Cartesian for the first one, p, and for q, Cartesian done in the same way. So we've got our position vector for q is 2ti and plus 20 minus 5tj equivalent to xi plus yj. So parametric equations, x equals 2t, or in other words, t equals x on 2, which we know is going to be handy. Y equals 20 minus 5t, and we've got a substitution. We've got 20 minus 5 halves of x. Okay, so that's the Cartesian story for q. Now if you've got them in y equals mx plus c form, this is how you'll solve them simultaneously, but you could have written them in implicit or standard form, and you could use other methods for simultaneous equations here. So basically I'm going to add 5 halves of x to negative 1 half of x, and you get 4x over 2 here, and we're going to take 10 off both sides and 2x there, so x equals 10 divided by 2, which is 5. Now we sub that into one of the equations. Let's choose that one there, and y equals 20 minus 25. Sorry, that's the wrong equation. Try that one there. 20 minus 5 over 2 times 5. Glad I caught myself then. And that's 25 over 2, which is 12.5, which is 7.5. So we have the point 5, 7.5 is where they collide when we're talking about Cartesian story. So they collide there, and graphically, using technology to verify, you can see that that's true. Yeehaw!